In this video, we'll be looking at rational inequalities. Now, the rules for how to evaluate a rational inequality versus how to solve a polynomial inequality, the rules don't actually change all that much, except for the only difference is the fact that you're going to have everything factored still equivalent in some way to 0, and then the bottom term simply, you can't have those things be 0. Now, we're still going to go ahead and treat them as though they're going to be equal to 0, very much like we did with the polynomial, but the change is that we're going to make sure that those values can't be solutions and never will be solutions, unlike that with the polynomials where all of the values are basically solutions or open circled value solutions until we decide based on your inequality written values. Now, so if I'm playing with this thing here, I'm going to go ahead and I'm going to set everything equal to 0. Again, I'll set the top equal to 0. Notice how I've already got it factored. I felt like doing that step is not necessary, but I'd set the top equal to 0 first. And then I would set the denominator equal to 0 second. When setting the top equal to 0, we're going to solve that, and if the equal sign is here, we're going to remember that those values should be filled in circles, okay? With that equal sign here, those should be filled in circles. But down here at the denominator, no matter what this symbol is, the denominator can never be equal to 0. And therefore, these are simply not equal values, but they're breaking points in the graph. They're again, the important pieces of values where the function could potentially cross the x-axis. So with that being said, this is going to give me x equals to a negative 1/3. This one is going to give me x equals to a negative 4. This one's going to give me x is equal to, or I should put not equal to, a negative 1. Not equal to, but still an important point. And x equals not equal to a positive 3. Again, not equal to, but still an important point. Up here, I'm going to leave the equal signs as they are, but just remember again, with the less than or equal to symbol, those two values could be filled in circles, while these two values will never be filled in circles. If that equal to symbol wasn't there and it was just the less than statement, well then these two values up here would also be open circles. Everything in this solution set would be open circles other than the lines that we draw between after checking values. So with all that being done, we're going to go ahead and create that number line test, just like we did with the polynomials. Again, not changing any of the steps that we followed, other than the fact that when we plug them in, we got to make sure that the values in the denominator, again, can never actually happen. So let's see here. We're going to start with a negative 4, going to a negative 1, going to a negative 1/3, and then finally a value of 3. Those are my 4 values that I have. Those are my 4 what I might call critical points. I'm going to draw, again, my table, making sure that I have my section for my intervals, my section for my test values, and then finally my plug-in section. Okay? So with all that information identified, what I'm going to do right now is I might as well fill in what I can in terms of equivalence and not equivalence. I know that negative 1/3 and negative 4, based on this inequality symbol, can be equal. So I'm going to go ahead and put hard circles on negative 1/3 and a negative 4. I'll also note that because these two factors were in the denominator, no matter what this sign is, those two are going to be open circles. And yes, this will always be consistent about how you set these things up. If you can, I would recommend doing these dots first and foremost. This also allows you to do all of your intervals relatively smoothly. I'm going to go from negative infinity to a negative 4, and because of that filled in circle, I know it's a bracket, bracket negative 4 to a negative 1. I know that that's going to be open parenthesis because, again, we can't include negative 1. I'm going to go from negative 1 to negative 1/3, bracket on that, negative 1/3 to 3, open circle on that, and 3 to infinity. So now I have all my intervals listed. I just have to test which out of these sections should be viable options to work. Now remember, we're doing less than or equal to 0, and when I plug these numbers in that I'm going to test, I'm testing them again in the factored form because I think it's more efficient. So the values I'm going to pick are going to be negative 5, over here negative 2, in here this is an unfortunate setup, but I'll go ahead and pick negative 1/2. I'm hoping that that's not going to be terribly problematic for me. Over here I'll pick 0, and then finally I'll pick 4. When I plug in negative 5, I'm going to have negative on top for the first factor. My next one over here is also going to be negative. I'm going to divide by that a negative and a negative, so it's negative times negative is positive, negative times negative is positive, positive divided by positive, and I'm going to go ahead and simplify this ever so slightly. Positive divided by positive is not negative, so this is actually greater than or equal to 0, and therefore that section shouldn't work. Okay, one more time, very slowly, or at least a little bit slower. When I plug in negative 5 into these each individual factor, that becomes negative, that becomes negative, that becomes negative. Negative times negative is positive, so it's positive on top. And then negative times negative is positive on the bottom, and positive over positive is going to be positive, not less than or equal to 0. So that section shouldn't work. And all of these values are going to be done exactly the same way. So when I plug in negative 2 for the first factor, I'm going to get negative 6 plus 1 is negative 5. So negative, that's going to be positive. The bottom is going to be negative, and that one's going to be negative. And therefore, I'm going to have a negative on top and a positive on the bottom, and that's going to be less than or equal to 0. So that section should check. When I plug in negative 1/2, I'm going to have negative 3/2 plus 1. Negative 3/2 plus 1 is going to be more negative than it is positive. Negative 1/2 plus 4 is positive. Negative 1/2 plus 1 is positive, and negative minus 3 is negative. So that's going to be negative over negative, which is going to be positive, and therefore shouldn't check. When I plug in 0, positive, 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 negative, and therefore that should be less than 0 and checks. And the last one, if I follow my understanding of how these things work, because this factor doesn't repeat itself, we should be comfortable with the fact of saying this one should simply just not work. Again, because it does alternate every single time unless special cases occur, which is why, again, you should always make sure that you still check them. But every so often, if you're comfortable with what those special cases are, then you can go ahead and use that skill to efficiently identify these values. Again, if you're not comfortable with it, when I plug in 4, positive, 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 and therefore is greater than 0, and greater than 0 is not what I want. So those are my two solution sections, and all I need to do is fill in the line cutting between those two values, and therefore my solution to this is going to be negative 4 to negative 1 with a bracket on negative 4 and an open parenthesis on negative 1, union with a bracket negative 1/3 to 3. And that's my set of values that I'm looking for in terms of this particular problem.